Now say in this question, what is the shortest wavelength present in Paston series of spectral lines? You know, we have done spectral lines of hydrogen atom and we have got the relation 1 upon lambda is equal to R into 1 upon N1 square minus 1 upon N2 square. Here we know the value of R, that is Rydberg constant, that is 1.097 into 10 raised to power 7 per meter. Now, we have to get the shortest wavelength. It means lambda has to be minimum. Lambda has to be minimum means this whole thing should be here the smaller value, and the larger value, the largest value, and this whole thing should be have the larger value. So, we can write for the Paston series, in Paston series N1 is equal to 3 and N2 is equal to 4 5s like this to the infinite. So, if we take N1 is equal to 3 and N2 is equal to infinite, then this should be maximum this whole thing, and because of that lambda will become minimum. So, we can write 1 upon lambda minimum is equal to 1.097 into 10 raised to power 7 into 1 upon 3 square minus 1 upon infinity. This term is now 0. So, we will be getting 1 upon lambda minimum is equal to 1.097 into 10 raised to power 7 into 1 upon 9. Now, we can go ahead with this. So, we have got this much. So, we can write lambda minimum is equal to 9 divided by 1.097 into 10 raised to power 7, that is here in meter. So, we can on solving we will be getting 8.204 into 10 raised to power minus 7 meter, or we can write down here 820.4 nanometer. So, this is the minimum wavelength of the the photons emitted in Paston series.